Welcome viewers to a new episode of the DENSO Tech Academy video tutorial series. Today I would like to introduce to you the new UR40 RFID Industrial Reader. And this is a quite new product from DENSO Wave. And I would like to give you a short introduction. What does it look like? How to connect it, what is important, and how the software configuration is working on this. So I have the device here. This is basically the UR40 base unit, which comes with a few connectors. I will give you an introduction to this as well. The base unit is including the controller and one built-in antenna here. And then we can have additional antennas, and we can connect up to 3 of these antennas to the device. So we can set up gates or environments where we can have up to 4 antennas integrated into one reading device, connected to one reading device. Good. So what else? We need some connections. We have here the connections for the external antennas. We have a connection for USB. We have connectors, and this is the most important one because we need to power up the device. As it is an industrial device, it requires an external power up to 24 volt, and we're supplying special cables. And this is the main cable which we would use because it has the connector to connect directly into the unit. And on the other end, we have an RS-232 interface where we can connect to a controller or PC or whatsoever host level device receiving the data, the read data over the RS-232 port. And we have some open ends. And on this cable especially, we have the power supply for the device. And we have some control lines, a trigger line, which we can use here and connect to the device. If we take the sample kits which we are providing a special modified cable. It looks a bit weird, but what we have here is the core cable. We added a connector port where we put the open ends onto the connector port so that we have an easy way for demonstration purposes to connect other devices or switches for this one. And we have added a connector for power supply. And in our sample kits, which you might receive from us if you want, we're providing a power supply which you can connect here, and then you can easily set up the device without needing special power supplies and stuff like this. So, okay, let's have a closer look onto the device itself. As already said, we have here the device. We have some status indicator LEDs for power, RF operation. So if the antenna is active, we see this here. Network or communication information here, and some status information here. As already said, we have the standard connector down here, which is for the. So I hope you can see this. Where we connect the special cable and have our power supply connected there. And then we have here an additional port for a special cable where we can connect a cable with some more connections for input and output ports which the device has. And we have here a connector for Ethernet network. So we're providing a special cable here with this connector on the one end and a standard RJ45 connector on the other end, which you can use to connect the device to an Ethernet network. On the top side of the device, it's difficult to see. I see this here. We have our 3 antenna ports to connect the external antennas. And we have here a USB port where we have a micro USB connector. It's locked and with some sealing, so we have the needed dust and water protection level here, but I can open this. And the USB port, we will use this later on in this demonstration setup as well to configure the device with the application, and as well we can use this connector or the RS-232 on the other end to receive the data which we have scanned. Good. So yeah, let's start. I will wire this up now and put the one connector in here. It's important to fix it properly so that we have it here. This is the one side, and on the other side I have a standard USB cable which I will plug into the USB port for configuration. Usually we would use this only for configuring the device with the software which we have, and we would receive the data on the RS-232 port, which then could be connected to a small PC or to an I/O device or a PLC or something like this. So this is the setup for the antenna. What I will do now is I will connect the power, and we see the power LED is lighting up, and the device is booting, and then at a certain stage it will be ready, and then it should be detectable. So let's have a quick look at the application. We're coming with an application. It's called Scanner Setting F. I will start up the application now, and the moment the application is starting up, it's checking the COM ports on the device and detecting if there are any devices connected. And it would search even, if a device is connected to the PC, we will see the device here. And we have here the device listed on the left side, and then we have all the configuration options here on the other side. I will make this a bit bigger so that we can see everything. Good. So what do we have here? We have we can configure the device. On the first tab, it's about the RFID and the operation mode. So we can configure the device as standalone unit, so it's working completely standalone, or upper level control mode. This means we can have an application directly connected to the device using the SDKs which we provide, and then the application can talk directly to the device, control the device, change settings and stuff like this. For the demonstration purpose, we are now using the standalone mode, and I have already done here some settings on the device, and we see all the settings which I have changed are marked in yellow. So I see that these are some changes which I already made. Let me check. I will initialize all settings. So this is the default settings. If you start up the device the first time out of the box connected to the application, then this is basically what you would see. Good. Okay, let's see. We have up to 16 conditions here, reading conditions, which we can use and configure according to our needs. For the first test, let's start with the first reading condition. We can leave everything as it is, because what we can set for each condition here is if this condition is activated, if what the condition is doing. We can select the communication mode with the RF tags if it is an inventory, what the condition is doing, or if we want to read certain data. So inventory means that we search for tags. If we find tags, we get the UII of the tags back. We can enable or disable here if we want to have, if we are in writing something to the device, if we want to have a verification, as we're doing in inventory. We are not writing to the tags, so we don't need this here. We can specify filters. Filters are quite can become quite complicated and complex. We can filter several conditions and combine these filter conditions. This is probably a topic for a separate session because for the filtering we need to know quite few information about the text, about the data we have on the text, and what we want to achieve with the filter. So this topic is quite complex, and I would like to skip this for this introduction here. Good, but we have the possibility to apply filtering to each condition, and we have, of course, for each condition which we configure, we can set up different filter values. We can define if we use the built-in antenna, if we use in which mode we're using it, if we use the horizontal orientation of the antenna, vertical orientation, or circular. By default it's circular, operating time in milliseconds, and reading and writing output. We can configure this here. I will leave this now for the default settings in this case, and then I can define if we have an external antenna connected and if we would like to use these external antennas. We have the same settings here. We can enable the external antennas and then specify the polarization value, the operating time, reading and writing output power for each single antenna on the device. Then for the tag communication, we can specify the link profile, we can specify other settings like Q value, session flag initialization, and the session flag. I would leave this all as default, and for the European model, of course, we can select the channels, we can select if we want to use all of the available channels in Europe, or if we want to pick for this condition a certain channel. Leave it as default here. So I will simply work with the default settings. They're quite good for the first start. Next thing we need to do is specify the communication. And as we're working in standalone mode, you see here the SDK mode is disabled, which is correct. And now we have to specify the interface where we want to receive the scanned data. And as I don't have the RS-232 port connected, but I have the USB COM port connected, I would select the USB COM port here in this case. I could pick Ethernet as well and have the device send the data via Ethernet, specify here IP address, protocol, and so on and so on. And the same, I need to specify some settings maybe for the RS-232. If I'm using RS-232 connector, then these settings could be important. As I'm using USB COM, I don't need to change anything here. The USB COM port usually adapts to the settings which I have here on the device and is managing this. Good. This is on the communication. Interface, Ethernet IP here. I have some more settings if I would like to use Ethernet protocol and the Ethernet connection in this case. Good. Let's have a look at the next settings. This is about the trigger. So by default, triggering the device is enabled using the input terminal. I would, because I don't have the input terminal connected, I mean, this is an industrial device. Let's consider we have a gate, a sensor gate, where packages or boxes are going through, and this sensor gate is then triggering the RFID reading, and then we would use the input terminal. And because we have the sensor gate connected to the input terminal, and then we would use this to trigger the reading of the device. In this case, for the demonstration purpose, I would trigger the device from my connected device, so from my PC, and using some commands. I have some default settings here for the commands. I would leave this. I can specify the trigger mode here if I would like to have continuous reading mode. So if I place if I send the command trigger on, then the device is active and reading everything which is passing across the antenna. If I put it in single mode, then this would mean that I place the trigger on and then it starts reading the device for a certain amount. I can specify here how long this should be in this case. I can specify the output timing, and I can specify fail notification. So if there is a reading error or something like this, I could get notification data sent in this case as well. So, but we leave it with continuous mode in this case, because then the device, we trigger it on, the device is working, we can place tags there, we can see what is happening. So this is the easiest way for the demonstration purpose. The next tab here is the output format. So I can specify here and enable or disable all the information which I would like to have transmitted. And so the first thing, I can specify a separator. So this could be comma separated, or I can even pick something here from the list which I would like to have. But I would leave it as comma separated. This is quite good readable then. I can enable a scanner ID, which if I'm receiving data using TCP/IP connection to a server, I can connect several UR40 devices to this server, sending data to the server, and then the server of course needs to know from which of the devices the information is coming. So I can enable here the scanner ID. I can enable a timestamp here. I can add some optional strings here if I would like to have something. I can specify the reading condition. This could be interesting if we're in the later part of the demonstration. I would show you to work with more than one condition in the standalone mode. And then it could be interesting to have this enabled here in this case as well. But I will leave it for now. I have the communication identifier. This is basically an information from which command and from which operation the data is coming. And then I can specify the RF tag data which I would like to have. I could specify it as ASCII response or binary response. For human readability, I will leave it with ASCII response. I can enable, disable the PC data from the tag, the received signal strength information. If I'm working with more than one antenna, it might be interesting as well to know the antenna. And the polarization wave, I can enable this. But for inventory, we see here, this is the mode which we are currently using, inventory. We always receive the UII information. If I enable the received signal strength, then here as well, we see this has changed. We have now the UII information, then a separator, and then the RSSI information as well. For demonstration purpose, I will leave this like this. Other settings which we could do, this is more about the input terminals and the output terminals, how we would use them. So by default, the input terminal 1 is specified as trigger signal. For all the terminals, I have these options, so I can reset the device based on a signal on one input terminal. If I have a reset switch or something connected like this, this is something which I could do here. So I can directly connect physical switches, so I don't need a PLC or something like this. I can directly connect physical switches to the terminals, and then if the physical switches have some chattering, then I can set up here some time to ignore chattering of the physical contacts. Same we can configure for the output terminals, and we have some options here as well. We can have a OK signal, no good signal, warning signal, error signal, or busy signal. So if we would like to connect a simple light stack to the device, we can easily do this on the output terminals, configure the terminals, and then we can have a light stack close to the device, which is then visually showing the people walking around what the device is currently doing and what is happening, what is going on. And then, of course, for the output, we can specify output timings if we want to have a delay, or if we can specify the length of the output. So if we say we configure terminal 1 as OK signal, let's say we connect there our green lamp from the light stack, then we can specify, so this would then be 500 milliseconds in this case, so we can put some value in here if we want to have it light up for 2 seconds, then we would enter this value here. Good. Finally, on the last tab, I get all the information and details of the device and settings and stuff like this. Now, finally, when I have done all the settings and changed the settings, we see this here, we have settings changed, and the moment we change a setting, we see here up in the corner the transmit setting button has changed and been activated, which is reminding us that we now have to transmit the changed settings to the device. So everything which we have done here now is just locally on the PC offline, and now I have to make sure by pressing this button that all the settings and the data is transferred to the device and the settings will be applied on the device. Okay, now this has been done, and yeah, now we can start testing this. And of course, for testing this, what we would like to have is we would like to have some RFID tags. So I put some RFID tags here on the device so that we receive any data. And then to test the communication, the easiest way is to go on the Tools tab, where we have a terminal. We can start up the terminal, and this is coming up with a screen offering the different interfaces if they are available or configured. I pick the USB COM interface and I say OK. And now I have here a terminal window which I can easily use. I need to start the terminal. Now I'm connected with the device. And now I have here some buttons, or I can type manually in here some commands and send these commands if I want to. But we have the trigger on and trigger off buttons already, which are sending the right command. And I will do this right now. And we see here the reply from the device. This is actually the device which, the reply which we would see then on the receiving device. And we see we sent the trigger on command, and we got a confirmation of the trigger on command with a status of 0, which is usually the status that everything worked fine. And then we get some command identifier, which is RFUGI, which is the information that the device is doing an inventory. And we see here I placed 3 tags on the device, but I have a few more tags here in the room, and we see it is reading not only 3 tags, but we have 3, 6, 7 tags right now, which we have received. So as it is in continuous reading mode, I can take some more tags and put them here, and then I get some more information shown on the screen. So it's in permanent reading mode. But each tag is read only once because we have configured this. I would show you this later on. We have configured this on the RFID tab that we want to have a reread prevention, so that each tag, if it is read once, this is the only data which we receive. And the antenna is now active, the radio field is active, and the tags are read several times now, but as we set this setting, we only receive the information only once. If a tag is already read, the device will remember this and then don't transmit the data. So now I can send the trigger off command, And again, we see here the command send to the device, and then we see the command confirmation with status 0, so the trigger is off now. And we see this here, the RF lamp is off. So try it again, trigger on, we get our tags read, trigger off, and the lamp is off again. Good. Let's stop this and close the terminal window. Let's go back here. Now let's play around a bit. The easiest thing, I was mentioning the double scanning prevention. The double scanning prevention, we can enable it in 2 modes, while scanning and while power is on. While power is on means that if I read the tags once and then stop the trigger, start the reading again, they will not be read again because the device is still powered on. So I have to power off the device first, and then I can reread the text. But for demonstration purpose, I would switch this to no double read prevention. I would put some tags here, and then you see we have changed the setting here. We have the yellow marker here on the setting. And the moment we change the setting, we get reminded that we need to transmit the data. I would transmit the data. And then once this is done and all the settings is transferred, I would start up the terminal again, go to Tools, start the terminal, select the port, start the terminal, OK. I would start the terminal, put the trigger on command, and now we see the tags are read several times in a row, and always the data is transmit. And we see now here the interesting value. I'm moving the tags around a bit because then the reading is much easier. So we see that that we read the information several times, but the last bit of the value is changing, and we remember I switched on the received signal strength. So we have here some information about the received signal, which gives us some information about how close the tag is to the antenna. We have configured 30 dB output power for the antenna. I left this as the standard setting. So the reading range is quite large with this setting. So I'm working here in a very close environment, but you can test it then in a live environment or test environment. That if we mount the antenna properly onto a wall and then start walking away and closer to the ticket, we always see this information then changing and having always the same tag information, tag data information. Good. Okay. So this is basically the functionality and the possibilities we have with the setting application. One more thing I would like to show you, and this is what happens if we're using different conditions. Let's say in condition 1, we would do an inventory to know and get the information which tags we have in the reading range of the antenna. And now we enable a second condition. And in this condition, we want to read additional information from the tag. So to read additional information, I need to specify what do I want to read. And in this case, I would like to read the TID data of the tag, so the TID bank. I would like to start the reading at position 0, and I would like to read, let's say, 6 bytes. If a bank is locked and needs a password, then we have here the possibility to set the password, but we leave it with a default password because all my tags here are not locked and secured, so they're all open using the default passwords, and this is what we would do right now here. So I apply this setting. We see this has changed here. Everything else I leave as standard. So now I have 2 reading conditions. And what is important is in the standalone mode, if we have the more than one condition defined, the device is cycling through the reading conditions. So it will start with condition 1 and use this condition for the operating time. 16, so 1.6 seconds, about 2 seconds or something. And then it will switch to the next condition and read and operate in the next condition for the same amount of time, and then go back to the first condition. If I activate a third condition, it will go this condition, this condition, this condition, and then back and start again the loop. So this is basically how this works. What is important in this case, if we want to test this, is that we disable the double scanning prevention, because otherwise we won't see anything happen when it goes into the second condition, because we have read the tags and already in the inventory condition, and then we don't get the data again if we are in the condition 2. So this is important to have this set up. Everything else we leave as it is. Oh wait, no, in the output format, to get a better information about the condition, we enable the condition information so that we know from which condition is the data coming. Good. This is everything I would like to change here for now. Transmit the settings to the device, and once this is done, I will start again the terminal, have my tags here, and then we see what will happen. So the transmission has completed. I go to the tools, start the terminal, select the port, connect, and start the terminal. And now once I start the trigger on, this is happening. And we see here what is going on. So we are doing inventory, tag reading, and then we're going into, I will stop this so that we can see this here. This is data coming from condition 1. It stays in the condition 1 for 1.6 seconds and then switches to condition 2. And this is then the data we receive from condition 2. So we have here again the UII of the tag. It's the same UII which we have here in the no wait, it's not, it's the D87B, it's this one actually. So this is when we read the tag during the inventory, and then we go to the second condition. We have the same tag here, but then we have the additional data, the TID data, which is specified here in this case. Yes. No, wait. This is the signal strength. This is the status of the reading of the TID, and this is the 6 bytes TID data which we have received. So this is according to the output format. We can double check the output format. I will stop this, close this, check the output format. If we are in the read condition, we get the data length, reading condition, communication identifier, the UII, then the signal strength, because we have activated the signal strength, the tag communication result, status, which should be 0, then everything worked fine, and then finally we get the data here. Yeah. Basically, this is everything we can show for this short introduction. So I hope you got first good impression of the device, and if you get a sample kit from us, then you know how to start and where to start with the device. And I hope that the tutorial was useful and helpful for you. Of course, if you want to see more video tutorials from the DENSO Tech Academy or other video content from DENSO, please check out our channel or subscribe and hit the notification bell below so you don't miss out on new videos. That's it for now. Thank you very much, and bye-bye.